So these are one of the easiest questions you'll ever get when they're asking you about a quadratic function. So we're going to identify minimums or maximums. So a quadratic function always has this shape. It's either a upward parabola or it's a downward parabola. In terms of calculus, because, why not mention it? This is what we say is concave up, so it's going up. This is what we say is concave down. So I like to draw little smiley faces. Smiley face up, oh, sad face, that goes down. So the way you figure this out is all based on your first value, the leading coefficient. If your leading coefficient is positive, then you have a minimum. So this is a positive happy face, which means you draw a smile. That smile, that smile has a bottom point. That's why it has a minimum. You do the same thing on the other side, right? So if that first term is negative, that's so sad, right? Oh, so we draw a sad face. Negative, sad, and if you draw it, you'll see that there's a maximum value. There's a top point, and then it goes down from there. Oh, that's so depressing. Um, so for this, really the only thing we need to look for is the a, the coefficient of the x squared. So 9 plus 8 ninths x squared, there it is. 8 ninths is in front of the x squared. That's positive, which means we have a smiling parabola. This has a minimum value. And if you need to find the minimum, well, that's at the vertex. And I have a video on how to find the vertex also. So let's get a little more complicated and look at a word problem. So here, the cost in dollars of manufacturing X bicycles at a production plant is given by the function below. So first, let's just cut to the chase. It's a word problem. So it says the cost C in dollars. That means C is cost. Manufacturing X bicycles. X is a number of bicycles. So when you're doing word problems, if they're giving you a variable, they're telling you right there what it is. So part A says, find the number of bicycles that must be manufactured to minimize the cost. You are finding the number of bicycles. Bicycles is X, which means you're looking for X. That's what it's asking for. So it's asking what's X to minimize the cost. Minimize means at the minimum. What is the X value at the minimum? Part B is saying find the minimum cost. So cost is C, so we're looking for the C value. I did this before. C of X really just means Y. So if you want to rewrite it as Y, that's what you're looking for. What's the Y value? Again, at the minimum. So the first thing we need to do is identify what is the minimum value. I know it's a minimum because it's starting with a 3x squared, right? So the cost function is 3x squared minus 1200x plus 131,000. This is a calculator question. Don't be a hero. So it's a minimum. The minimum is going to happen at a vertex. The way we find a vertex is we find the x value, negative b divided by 2a. So we plug in these values. Negative 1200 over 2 times 3. So our x value is going to be 1200 divided by 4, 300. I hope that's right. Nope, it's not right. I did the math wrong. So see, this is why you always write it all out. 1200 divided by 6. So it is 200. So 200 is the minimum value. So part A, find the number of bicycles that must be manufactured to minimize the cost. So part A is 200 bicycles. Oh man, I'm on a roll today. Bicycles. All right, so that's the number of bicycles to minimize. And to find the Y value or the C value, we have to take that 200 and plug it in. So what is C? What is the cost at or when there's 200 bicycles? So 3 times 200 squared minus 1200 times 200 plus 131,000. So just plug the whole thing into the calculator. You don't have to do piece by piece. And that gives us 11,000. So the cost at 200 bicycles, or the Y value, is 11,000. So it's asking for the cost. The cost is $11,000. That's how you identify minimums and maximums. Easy peasy.